Here's your actuator's dirty secret. Every watt it doesn't use turns into heat somewhere in your circuit. And if you don't know exactly where that heat is going and how much there is, you're going to burn out MOSFETs, melt connectors, or slowly cook your power supply until it fails at the worst possible time. That's exactly what this heat dissipation calculator solves. It handles the two biggest heat sources in actuator control systems. First, your AC to DC power supply conversion losses. Second, your MOSFET switching losses in PWM controllers. You plug in your values and it gives you exact watt figures, BTU per hour conversions, and the maximum heatsink thermal resistance you need to keep everything alive. Here's the core idea in plain language. Your power supply rated at 85% efficiency is losing 15% of every watt as heat. The calculator takes your input voltage, output current, and efficiency rating, then tells you exactly how many watts are being dumped as thermal energy. On the MOSFET side, it factors in your on resistance, duty cycle, switching frequency, and gate charge. Because at 20,000 switching cycles per second, even tiny per cycle losses stack up into serious heat. So where does this matter in practice? If you're building a multi-actuator control cabinet and need to size ventilation or heat sinks before everything is assembled, this gives you real numbers. If you're selecting between two MOSFETs and want to compare which one generates less heat at your operating frequency, now you can quantify the difference. Or if you're debugging a system where a power supply keeps thermally shutting down, you can calculate whether your load is simply exceeding the thermal budget. This isn't guesswork. It's the math your components need you to do before they fail. Find the link in the description below to use this calculator and read the full engineering guide.